This is the drawer with a blind dovetail joint and Blum soft close hardware. I designed the drawer in Fusion 360 and cut it on Shapeoko Pro CNC. You don't need a special vertical mount on CNC to do this cut. In this video, I will show you the design procedure and the CNC toolpaths. I will also show you how to install the Blum soft close drawer hardware. This is the Blum drawer hardware I used. There are 15 inches runners and locking devices with side-to-side adjustment. The runners I used are in 563H series. Blum has detailed charts to show the specifications, including how to calculate drawer width from drawer opening, the size and location of back notch. We need to use these specifications in the design procedure later. To cut tail sockets on the pin board, I will use this Microjig Dovetail Bit. This bit has round over corners, which is helpful for cutting the tails on CNC. Now let's start to design this drawer. First, I will define some parameters. Sideboard thickness is the thickness of the 4 sideboards. I will use 1/2 inch Baltic birch plywood, so the thickness is 12 millimeters. Bottom board thickness is the thickness of the bottom board of the drawer. I will use 1/4 inch Baltic birch plywood, which is 6 millimeters thick. The depth of the drawer is same as the length of the Blum runner, which is 15 inches. The width of the drawer is calculated from the width of drawer opening. My drawer opening is 25/16 inches. The height of my drawer is 5 inches. Dovetail height is determined by the Microjig Dovetail Bit. Dovetail width is the width of a pin socket. I use 5/8 inches here. Dovetail angle is also determined by the Microjig bit, which is 14 degrees. Now let's create the first component, the right tailboard. Then create a simple rectangular sketch to define the overall dimensions for this tailboard. Since we use blind dovetail, the length of this tailboard is not equal to the overall depth of the drawer, so we need to do some calculation here. After finishing the sketch, I extrude it into a body, and then I will create another sketch to define the shape of the pin socket. I will create 2 construction lines here to help us to constrain the shape, then use the line tool to draw the basic shape of the pin socket at the center of the board. Then use dimension tool and the symmetry tool to set the tail angle to 14 degrees and the pin socket width to 5/8 inches. After finishing the sketch, I extrude this pin socket. Then I use the pattern tool to generate other pin sockets on this tailboard. For the number of sockets, I just use a hard-coded number 5 here. For the distance, I use height divided by 2 and minus 1/8 inch. This is to make the half pin socket at the edge a little bit bigger, so the half pin on the pin board can be stronger. Click OK, then we have 4 tails now. Next step is to create another sketch from the top of the tail board. This is to create a 14-degree angled surface to match the toolpaths of the dovetail bit. And this can also help to hide the dovetail joint from the inside of the drawer. You will only see a straight line in between the boards from the inside of the drawer. So after this cut, the tails will have a 14-degree surface on 3 sides. Then let's create a middle plane. Then we can use Mirror Tool to mirror all the features we just created to the right side of this tailboard. Now this tailboard is finished. After saving the progress and going back to the top level from the browser, I will create a new component, Subface Board. Then I create a sketch for this board, just a simple rectangular, then extrude. This is the basic shape of this Subface Board. We will create the pins later. Then generate a mid-plane and use the Mirror Tool to create the tailboard at the left side. Then I copy the Subface Board and paste new to another component. We will use this new component as our backboard. We need to use paste new here, as the backboard will be different from the Subface Board later. Then I use the joint tool to move the backboard to the right location. Now I need to create the last component, the bottom board. To draw the sketch of this bottom board, I will project the 4 existing boards and draw 4 construction middle lines. Then just use collinear tool to constrain the rectangular to these middle lines. Then we can extrude the bottom board. Based on Blum's specification, the bottom board need to have a half-inch recess. For the thickness, I just use the parameter we defined already. Then I need to create the notch required by Blum on the backboard. So I choose the backboard and create a sketch. It's just a rectangular with required width and height. Then finish the sketch and extrude the notch. Then I can use the mid-plane we created previously to mirror the other notch at the right side. Last step is to use the Combine tool to finalize the shape. We will use Cut operation and choose Keep Tools. With the Combine tool, I can make the pins on the Subface Board and the Backboard, and make dado slots for the bottom board on all the 4 sideboards. That's it. The drawer with blind dovetail joints and fit for Blum soft close slides. Let's final check the shape of each board. To prepare for the CNC cut, we need to go to the manufacturer workspace, click Setup, create a manufacturing model, then right-click the manufacturing model and choose Edit. Now we can make modifications to the model for CNC job, and these modifications won't impact our original design. First, we can create a rectangular sketch and use the Arrange tool to generate the layout for CNC cut. Just select the 4 sideboards which will be cut on CNC, and then select Rectangular Sketch. If we want to flip one of the boards, just click the small icon in the object list. Then I will do some shape adjustments for the CNC cut. Before talking about these adjustments, I need to tell you that these adjustments are based on my trial and error test. I made 5 test pieces before making the actual drawers, but the dovetail on my actual drawers can still be improved. I will further fine-tune this adjustment in future. If you have suggestions for these adjustments, please let me know. First adjustment is to offset the tail surface for -1/64 inches, as this tail surface will be cut by 3D toolpaths and won't be perfectly match the design. Then I will create 3 different roundovers to match the shape of the dovetail bit. For these edges, I will use 3/16 inches roundover to match the dovetail bit radius. And for these edges, I will use 1/32 inches roundover to match the bottom cutter radius of the bit. And last, for these edges, I will use 3/64 inches roundover. That's all the edits for this manufacturing model. Then we can create setup and toolpaths for the CNC cut. Before I introduce the toolpath, let me show you the 5 bits I will use. They are 1/4 inch downcut bit, 1/8 inch downcut bit, 1/8 inch bore cutter, 1/16 inch downcut bit, and the dovetail bit. I will use the 1/4 inch downcut bit for the first and second toolpath. The first toolpath is to cut the contour in multiple passes, and the second toolpath is using 3D adaptive cleaning to do the relief cut for the tail sockets. For the next 3 toolpaths, I will use 1/8 inch downcut bit, first to clean the edges and corners of the previous contour cut by 1/4 inch bit, and then clean the tail sockets. The last toolpath for this 1/8 inch downcut bit is to cut data slots on all the 4 boards by using 2D pocket toolpaths. Then I will use 1/8 inch ball cutter to do 3D adaptive toolpaths for all the tails. I separate them into 4 toolpaths to avoid unnecessary travels of the cutter between groups. For the last toolpath, I will use 1/16 inch downcut bit to clean the tail contours and use Dovetail Bit to cut the tail sockets. Now let's start to install the Blum drawer hardware. In my opinion, these Blum hardwares are actually easier to install compared with traditional drawer slides. First, we need to drill 2 holes on the backboard. Then we need to attach the 2 locking devices to the bottom of the drawer. I just marked the location of the holes, pre-drilled, and screw them to the subfront board. No need to use jig or template. To install the 2 runners, the only tricky measurement is the setback. Here is the setback equation for my inset drawer. After the runners are screwed on, then just place the drawer on the runners and push it into the cabinet. Last step is to install the drawer front. I use poker cards to hold the drawer front and make sure all the spacings are equal. Then use the holes for the drawer handle to temporarily screw the drawer front to drawer body. Then open the drawer and permanently screw the drawer front from inside. That's all for today's video. Thank you for watching again. If you like this video, please like and subscribe.